welcome to the lecture series of Mathematical Modeling of Manufacturing Processes with subject code KME 073. I am Dr. Suman Gotwal, working as an assistant professor in Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, in today's lecture, we are going to start the evaluation of different properties of the manufacturing product. So, these will be the outline of this lecture. So, different properties that we will start today in today's lecture will be the tensile test, compressive test, bending test, hardness test. In hardness test, we will focus on these two tests, BRINELL hardness test and the ROCKWELL hardness test. After that, we will study about the impact test, and in impact test, we will study about the ISO test and the Charpy test. Okay. So, all these tests we will study in detail today. So, first of all, we will discuss the tensile test. Okay. So, as we all know that the tensile test is performed on a machine that is known as the universal testing machine or UTM. So, you can see this is our UTM machine, and here we have the two cross head. One is the moving cross head and the another one is the fixed cross head. This is the base of the machine and this is the table. Okay. Now, we are as we are talking about the tensile test, so we are using the tensile force here. So, we can see the direction of these force is opposite to each other. Okay. And this is our test specimen. Okay. These are the columns. So, in this diagram we can see the test specimen. Okay. These are the at two end points, this is the collar, and from here we will fix it into the machine. This is the length in which we are going to measure the changes. So, this length is known as the gauge length. Okay. So, in this you can see here that when we apply the tensile force, then in that case the elongation will takes place. Okay. और अगर elongation हो रही है, it means the length will increase, and after a particular time the necking region will start, necking of the tool material will start. So, this is the necking region. So, in this region we can see here the dia of the cross section is less. Okay. And after that we will get the fracture point. Okay. So, in case of the tensile machine, हम क्या करेंगे, we will apply the load, different load, and at each point we will measure the length and area of cross section. Okay. And we will find out the stress and strain corresponding to these values. Okay. So, we will get this type of plot here. So, this is the stress strain diagram. So, which is a plot between the stress and the strain. So, as we all know that stress is the load upon area and strain is the change in length upon original length. Okay. So, in this diagram we can see from point 1 to point 2, okay, there is a linear relationship between the stress and strain. Okay. And this is the elastic region. Here it is the elastic region. So, what is the meaning of the elastic region? It means when we will remove the force, the material will regain its original shape. Okay. And these are directly proportional to each other. So, we can see here sigma is directly proportional to strain epsilon. Okay. So, this law is known as the Hooke's law. So, Hooke's law will follow between point 1 to 2. Okay. And we can replace it with the help of a constant which is E, and this E is known as the Young's modulus. Okay. So, we will get the value of E as the ratio of the stress and strain. So, at the point 2, this point is basically the yield strength. Here at point 2 we will get the yield strength. Yield strength का क्या मीनिंग है? Yielding means जब plastic deformation start होगा. तो अब beyond this point the plastic deformation will start. So, plastic deformation क्या है कि जब elastic region में material था तो when we were removing the load the material were regaining its original shape. But beyond point 2 there will be permanent deformation in the material. Okay. So, here we can say that here the plastic deformation will takes place. So, we can see from this point to this point, this is the plastic region. Okay. So, from this plot we can see here that the strength of the material is increasing. Okay. And why it is increasing? क्योंकि strength जो है material की वो increase हो गए. So, this region will be the यहाँ से यहाँ तक point 2 to point 3 will be the strain hardening region. प्लास्टिक डिफॉर्मेशन के कारण जो डिसलोकेशन हुई आपके एटम्स की, मॉलिक्यूल्स की, ओके, तो उसके कारण क्या होगा? स्ट्रेंथ जो है मटेरियल की इंक्रीज हो गई एंड वी विल गेट द स्ट्रेन हार्डनिंग रीजन हियर. एंड एट पॉइंट 3 द स्ट्रेंथ corresponding to the point 2 point 3 is known as the ultimate tensile strength. This is the maximum tensile strength. Okay. Beyond this, beyond point 3 the necking region will start. Okay. Means the strength of material will decrease. So, a small amount of force will required to deform the material beyond point 3. So, here we can see that this region is the necking region. So, necking area is this one, like this necking region. And at this point the fracture of the component will takes place. So, we can note down all these details. Okay. So, what are we getting from this diagram? So, it consists of two regions. First one is the elastic region and then second one is the plastic region. So, in elastic region we are getting the value of Young's modulus, we are getting the value of yield strength corresponding to yield point. In plastic region we are getting the ultimate tensile strength, we are getting the strain hardening region and we are getting the fracture point. Okay. So, this information we will get from this diagram. Clear? Next test is the compression test. Okay. So, compression test क्यों important? What is the requirement of this test? So, these tests are required to measure the elastic and compressive fracture properties of the brittle or ductile material जिसकी low ductility होती है. ठीक है. तो brittle या फिर low ductile materials शो होंगे, उनकी elastic या जो कंप्रेसिव फ्रैक्चर प्रॉपर्टीज है उसको फाइंड आउट करने के लिए वी कैन यूज दिस टेस्ट. ओके. एंड हियर आल्सो वी विल गेट all these points, like we will get the modulus of elasticity here, we will get the proportional limit here, we will get the compressive yield point, compressive yield strength and compressive strength. Okay. All these values we get here and this test is also performed on the UTM machine. And here the compressive force will act. Here we can see the direction of these forces, means these are compressive in nature. Okay. This one is our original specimen and its height is H0 or HO and this F force is acting here which is compressive in nature and this is the original cross sectional area. In case 2 when the compressive force is applied then the height is H, height change होगी क्योंकि compress हो रहा है and this area will become A, area will increase here. Okay. So, here the load is applied due to which the end of the cylindrical specimen squeezes. So, mostly we will take the cylindrical specimen, or end of this cylindrical specimen will squeeze here. So the same parts are there here. It is the moving crosshead, this one, and this is the lower platen on which the we are fixing the specimen. This is the upper platen and this is our test specimen. So this test we will perform. Okay. Now we come to the bending test. Okay. So in case of the bending test, why these tests are performed? So if we want to know the flexure or bending characteristics or the behavior of the structural elements which are subjected to the external forces, okay, which are perpendicular to the, and these forces are applied perpendicular to the longitudinal axis of those elements, then in that case we will go for the bending test. So here basically how the material will behave, how our component will behave when we are applying the external load on a component. Okay, and these applied force will be perpendicular to the longitudinal axis. Okay. So if we talk about the bending of the flexure test, so we have the two types of test commonly which we commonly used. First one is the 3-point flexure test and the second one is the 4-point flexure test or bending test. Okay, and the material which we used for the bending test are usually the polymers or woods, composites or the brittle material. So for these material we perform this test. So in this case you can see here there are two diagrams. This one is the 3-point bending test and this one is the 4-point bending test. Okay. So here you can see this is our specimen which is the cylindrical rod and it is supported by the two pins at the ends. So these are two supporting pins. Okay, and this is the loading pin and on which the force is applied at the center. Okay, so means it is supported at the 3 points, 2 points supporting point है and एक जो point है, एक जो pin है, that is the loading point or loading pin. So it is the 3 point, but it is the 4 point. Here we have the two supporting pin which are at the end and at two loading pins on which the force is applied. So it has two components of the supporting pin and 2 points of the load where the 2 points of the loading pins where the load is applied here. So it is the 4-pin flexure test. So how we will select whether we have we will go for the 3-point or the 4-point bending test. So if our material is homogeneous, like if we have the metals or alloys, polymers, then we will go for the 3-point bending test, because in case of the homogeneous material the properties are same at every point. Okay, but in case of the non-homogeneous where the properties are different in different directions and different at different points, then we will go for the 4-point flexure test to avoid the premature failure. Okay, and this premature failure will be due to the stress concentration and interlaminar shear. Okay, so this is the actual diagram. You can see here we have the rod here and this is the example of the 3-point test. Here we are it is also the 3-point bending test. Okay, here we have the rectangular specimen, here we have the cylindrical rod. Okay, so one question arises that why we perform these tests. So basically we know that when we perform the bending test, then we can see here the compressive force will act and compressive stress will act and here the tensile stress will act. But at the midline of the component, the shear stress will act. Here in the midline of the component, the shear stress will act, and to avoid the premature failure, we have to ensure that the material fails due to the tensile or the compressive stress only. Okay, in that case we have to minimize this shear stress. ठीक है, अब shear stress को आप कैसे minimize करोगे, तो इसके लिए हमारे पास एक depth ratio होता है, and depth ratio is basically the length of the outer span which is divided by the height of the span. तो इनका रेशियो हम फाइंड आउट करते हैं, एंड देन वी कैन मिनिमाइज दिस मिडलाइन shear stress failure, premature failure. ओके, तो इसकी एक स्पेसिफिक वैल्यू होती है कि अगर अलग अलग मटेरियल के लिए अलग अलग मटेरियल वैल्यूज होती है, तो इस वैल्यू को हम कंट्रोल करके प्रीमैच्योर फेलियर को अवॉइड कर सकते हैं और मिनिमाइज कर सकते हैं. ओके, then we have the hardness test. So hardness test, basically hardness क्या है, it is the resistance to the permanent indentation. Okay, permanent indentation से जो material की resistance है, that is the hardness. Okay, so good hardness means material is resistant to scratching and wear. So ये प्रॉपर्टी कहाँ रिक्वायर्ड होगी, जब हम टूल्स की बात करते हैं. तो टूल अगर हमने देखा हो तो मैन्युफैक्चरिंग में जो भी टूल्स यूज करते हैं दैट आर हार्डर टूल यूज किए, उनकी स्ट्रेंथ जो है, उनकी हार्डनेस जो है वो ज़्यादा होनी चाहिए, जिससे कि वो रेजिस्टेंट हो टू दी टूल वियर. सो मोस्ट ऑफ द मैन्युफैक्चरिंग टूलिंग मस्ट बी हार्ड इनफ फॉर द स्क्रैच एंड वियर रेजिस्टेंट, अदरवाइज उस पर मार्क आ जाएंगे जो कि क्वालिटी ऑफ प्रोडक्ट को अफेक्ट करेगा, उसकी टूल लाइफ को अफेक्ट करेगा, टूल जो है टूल की स्पीड को, टूल के जो डिफरेंट फैक्टर्स हैं उनको अफेक्ट करेगा अगर टूल वियर और स्क्रैचिंग आ जाती है टूल पे. तो हम मोस्टली हार्ड मटेरियल्स को टूल जो है वो यूज करते हैं, उनकी हाई हार्डनेस होनी चाहिए. Hardness tests are used for assessing the material properties because they are quick and convenient. ये बहुत क्विक होते हैं, टाइम कंज्यूमिंग नहीं है, इसलिए इसको यूज किया जाता है. मोस्टली हार्डनेस टेस्ट को यूज करते हैं हम लोग, एंड मोस्टली यूज हार्डनेस टेस्ट आर रॉकवेल एंड ब्रिनेल टेस्ट. बाकी टेस्ट भी होते हैं जैसे अदर टेस्ट जो अवेलेबल हैं, दैट इज विकर टेस्ट, नोब टेस्ट, ड्यूरोमीटर टेस्ट एक्सेट्रा. ओके, next in hardness test we have the first we will discuss the Rockwell test. So in case of the Rockwell test, basically the depth of the indenter penetration into the specimen, कि जो इंडेंटर है वो कितना पेनिट्रेट करता है स्पेसिमेन सरफेस में, वो बेसिकली हम मेजर करते हैं. ठीक है, तो इस केस में हम देख सकते हैं दिस इज द इंडेंटर. तो हम दो तरह के इंडेंटर जो है वो यूज कर सकते हैं. शेप जो है इनकी या तो स्टील बॉल के स्टील मटेरियल का बना होगा और बॉल शेप में है, लाइक दी वी कैन यूज दी हार्डन स्टील बॉल विद द डायमीटर 1/16 इंच और 1/8 इंच, और वी कैन यूज द स्फेरिकल डायमंड cone also, diamond shape indenter also with an angle of 120 degree. Okay, so in this case we can see here the initial position, we can see the indenter position here, and this is our specimen, this is the indenter with an angle of 120 degree. So we are using the diamond indenter here, and here it is final position. In initial position we are applying the minor load. In case of the final position, when we are applying the major load, then we can see this penetration of the indenter into the specimen. So we will measure this D, value of D. Okay, so here the hardness we can measure into different scales like A, B, C, D, E, F, G, H, K. These are different scale, and in number also we can measure it, and having no units. And aluminium alloy, copper alloy and soft steels are basically tested with the 1/16 inch diameter steel ball at load of 100 kg F. ओके, और इसको हम बोलते हैं रॉकवेल हार्डनेस स्केल बी. स्केल बी में हम जो है इसकी टेस्टिंग कर रहे हैं. नाउ वो तो था थोड़ा सॉफ्ट मटेरियल जब हम यूज कर रहे हैं, लेकिन फॉर हार्ड मटेरियल के लिए जैसे कि हार्डेस्ट अलॉयज, हार्ड कास्ट आयरन, these are tested with the diamond cone with the load 150 kg। तो जितना हार्डनेस इंक्रीज हो जाएगी उतना ही लोड भी हम इंक्रीज कर रहे हैं। सॉफ्ट मटेरियल का केस था तो वी वर यूजिंग 100 kgf, बट हेयर इन केस ऑफ द हार्ड मटेरियल्स वी आर यूजिंग 150 kgf load, and it is known as the Rockwell hardness scale C. Now we are taking one example like 53 HRC. What is the meaning of this? It means the 53 units, this number is showing the units, and which is measured by this in the scale C by the hardness Rockwell. HR is the hardness Rockwell, C is showing the scale, and these are the number of unit. Now we have the Rockwell superficial test also, and this is basically done in case of the thin stripes, coatings, carburized surfaces, etc. Okay, so these are the thin stripes, material thickness is less, so it means the force की requirement होगी वो भी कम होगी। तो यहाँ पे आप देख सकते हैं here the reduced load means up to the 15 kgf and 30 kgf required होगा as a major load, and reduced preload of 3 kgf only are used in the superficial test. Okay, so this is the same diagram which this is the scale N and this is the scale T. Okay, and these are the values of the load here. Here we are using the diamond cone shape, and here you are using the steel bowl shape indenter. Next we have the BRINELL test. So in case of the BRINELL test, here a hardened steel or tungsten carbide for extremely hard materials बोल यूज की जाती है। यहाँ पे हम बोल यूज कर रहे हैं, लेकिन उनका मटेरियल जो है वो डिफरेंट होगा, दैट विल डिपेंड ऑन द हार्डनेस ऑफ द मटेरियल। तो उनका जो डाया होगा दैट विल बी 2.5, 5 और 10 mm in diameter. Okay, so it will be used as the indenter. The loading force is in the range of the 300 to 30,000 Newton. तो यहाँ पे फोर्स जो है, फोर्स की रिक्वायरमेंट जो होगी वो डिपेंड करेगी ऑन द हार्डनेस ऑफ द मटेरियल. ओके, एंड इट इज यूज्ड फॉर द मेटल और नॉन मेटल, दोनों के केस में यूज कर सकते हैं लो टू मीडियम हार्डनेस के लिए. तो हेयर वी विल गेट ए ब्रिनल हार्डनेस नंबर. सो वी कैन फाइंड आउट द हार्डनेस ब्रिनल हार्डनेस नंबर as the load divided by the indentation area. Okay, so this is the formula for this. This is the load applied. dB is the basically bowl diameter, and di is the indentation diameter. This one, this is the indentation diameter. So with the help of this formula we will get a number that will show the BRINELL hardness. The last test is the impact test, and impact test basically used to show the ability of a material to withstand the impact. ओके, कि कितना जो है अगर सडन लोड आता है तो उसको कितना वो बियर कर सकता है कोई भी मटेरियल. तो इट इज बेसिकली यूज्ड टू प्रेडिक्ट द बिहेवियर ऑफ द मटेरियल अंडर एक्चुअल कंडीशंस. Okay, so these tests basically showing the amount of energy that is absorbed during by the component during the fracture. Okay, so we have the two types of test here. First one is the Charpy test and the second one is the ISO test. So both are impact test. Here the direction of hitting is this, and we have a notch here. So here we can see that it is the direction of hitting. Here the notch is in the opposite direction, and here the notch is in front of this. Okay, तो notch की जो placement होगी that will be different here. ओके, सो अगर हमारे पास डक्टाइल मटेरियल है या ब्रिटल मटेरियल है तो ब्रिटल विल एब्जॉर्ब द लेस अमाउंट ऑफ एनर्जी व्हेन इम्पैक्ट टेस्ट इज परफॉर्म्ड, एंड जो डक्टाइल मटेरियल होगा वो जो है लार्ज अमाउंट ऑफ एनर्जी को एब्जॉर्ब कर लेगा. क्लियर? सो this is all about the different tests that we can perform on our material to check what type of characteristics and what type of behavior of that particular material is. Okay, so this is all about today's lecture. In next subsequent lectures we will start the mathematical modeling. So thank you so much.